Hello, this is Steve Koster with Espresso Engineering, and we're still here in Denver at the EMC Symposium. Today we got a chance to catch up with John Zawotny of Rohde&Schwarz. John, how are we doing today?
Pretty good, Steve. How are you doing?
Very good, thank you, man. The show's been good for you?
It's actually been great, yes.
Terrific. Now, Rohde&Schwarz has got some new equipment out.
We do. What I wanted to talk to you about today is a new receiver that we're introducing. It's called the ESR26. It goes up to 26 gigahertz, and what it's doing is it's meeting some new requirements for the FCC and Mill Standard and CISPR committee.
Terrific.
And so I wanted to, what the ESR is all about speed and intelligence. So I wanted to go through a couple of things, some of the new features on the analyzer so that people can get a feel for how it's going to make their life easier in the EMC testing community.
I know a bunch of engineers that want to know that information.
Okay, great. And right now we're looking at a traditional step scan, so the analyzer is moving along in a step scan mode, and you can see the speed. We have a peak detect and a quasi-peak detect going. That's what the two traces represent. So what I want to show you today is what happens when we turn on time domain scan. So what I'm going to do is I'm going to stop the scan, and I'm going to go to test automation and hit scan, and I'm going to turn on this button called time domain scan. And now when I hit run continuous, you can see the dramatic speed improvement that is going on here. So we're using FFT analysis in order to do this. We're taking FFT analysis in 30 megahertz spans, and we're stitching them together and then displaying those real time on the analyzer. It's a huge speed improvement, and what that means for the customer is that they're able to do their design updates quicker and get their product out the door faster. Okay? So the next thing I wanted to show you is we also have a spectrum analyzer mode. So all of our receivers have a traditional receiver mode and a spectrum analyzer mode. So what I'm going to do is to show you this, I'm going to hit center. I'm going to center at 100 megahertz. And then span 40 megahertz. And I need to change my input. We have two inputs on the analyzer, so I'm going to change this over to input 1. Span at 40 megahertz. And frequencies at 100 megahertz. Sorry, I had some bad key pushes there. So anyway, this is now a traditional spectrum analyzer. We're looking at a swept tune mode, just like any other spectrum analyzer would work. So we allow the user to use it in a receiver mode or a spectrum analyzer mode. And you can analyze your signals, look at different frequencies, different spans, just like you would with any other spectrum analyzer. Now I want to show you something that we have that's called real-time spectrum analysis mode. So I've got a tab here. I'm going to turn this on. And what I'm looking at now is we're doing an FFT, and we're doing an FFT in a 40 megahertz span. So anywhere across the frequency range of the analyzer, we can look at a 40 megahertz wide window in what we call real-time mode. So it's a 40 megahertz wide FFT. And so that's what's being displayed on the bottom grid here. And up on the top grid, we actually have a spectrum display. So on the y-axis, this is time. And you can see the different peaks that are appearing based on the different peaks that are in the spectrum mode. So if you have any instantaneous signals that are causing you problems, that are really hard to catch, that you would not catch in a swept tune spectrum analyzer, in a 40 megahertz real-time analyzer mode, we can capture those. We can capture those, we can stop this, and we can actually play this back, and you can see what happened just prior to that and just after that. So if you do catch an intermittent signal, you can catch it on here, and we can capture that, and then we can actually scroll back through, and you can see what happened just previous to that event, right after that event.
Sometimes the intermittent signals are the hardest ones to debug.
Exactly.
So that's
exactly.
a great feature.
So, okay.
Oh, super, man.
So anyway, we're in booth 701. Please stop by. If any people have any comments, questions, I believe this will be on YouTube. Please post those questions out there, and we'll be happy to get back with you and answer those.
Terrific. Thank you very much, John.
Okay.
It's really exciting to see that.
All right. Thank you,
Again,
Steve.
This is Steve Koster with Espresso Engineering from Denver saying have a great day.
Thank you.